A very good day. My name is Farah Aina binti Azhar, and today I am going to give some updates on my FYP project on fire forensic for photovoltaic fires. So to start off, chapter 1, 2 and 3 of my thesis are done and I have submitted it to my supervisor for review. And also a survey had been conducted to 111 solar energy companies that are listed on the official SEDA website. The responses for the survey had been recorded and analyzed. Also, an experiment on heated PV subcomponents had been executed this week, and I am currently working on FMEA based on the literature review as well as on the survey response. Also, I am interpreting the results and working on chapters 4 and 5 while improving chapters 1, 2, and 3 of my thesis. So now I'm going to explain a little bit further on the failure mode effects analysis. So I have conducted a survey and these are the responses from the survey. Out of 111 of the companies that I sent the email to, I only got responses from 6 of the companies. So here are the list of the companies. And so you can see the kind of questions that I asked. Basically, the kind of questions that I asked involve the failure modes of the PV subsystem. So for example, the common failure modes in a PV module, also on the inverter, connector and wire failures, also what are the type failures that are typically found in a PV system. I also asked if the person answering have observed or heard of a PV system failure that lead to fire in Malaysia and other safety issues basically. So from this survey, I am able to gauge kind of like the frequency of the failure modes of certain PV subcomponent. So from here, I have downloaded this template for FMEA, for system FMEA from fmea.co.uk. And basically, this template will help me organize the failure modes and giving the rating for the severity, occurrence, as well as detection. So for the failure modes, causes and effects, also the potential failure mode, I get it from literature review because there is extensive studies on the failure modes, causes and failures. So from there, I can also give rating for the severity, occurrence and detection. I gauge from both the literature reviews as well as from the survey. Since the survey only got 6 responses, I cannot depend solely on the responses. I have to still refer to literature review reading, and then from here we have 3 different probabilities. We can get the RPN number by multiplying the severity rating, the occurrence rating, as well as the detection rating to get the RPN number. So for RPN number, as the number increases, the seriousness of failure mode it also increases. So when the RPN number exceed a certain threshold number, which is usually half of the maximum RPN number, that means that the failure mode needs to be an action needs to be taken on the failure mode to prevent it from occurring or to reduce the damage done when the failure mode does occur. So basically that is what I'm working on for the FMEA. Next, for the experimental part of my FYP, so this is the experimental setup. We have a PV module which I put it inside of a fume hood so that we can collect the product of combustion of the wires. So the reason why I only burn the wires is that this will kind of imitate the internal resistive heating inside of the wire. The reason why I don't burn the whole PV panel because that would not be relevant to my project, because I mean it is a good study because we can study on the kind of emission from the combustion of the PV module, but that is not one of the failure modes. So one of the failure modes of PV module is the increased resistive heating inside of the wires. So when the resistive heating increases, that would also increases the temperature of the wires inside of the insulation. So basically from here we can see how does the resistive heating affects the PV module and how the failure mode occur. So the parameters that I observed for this experiment includes the temperature of wires at W1 and also W2. So we only apply heat at the W1, and also we observe the voltage and current of panel under irradiance before and after the experiment. The function of observing the voltage and current of panel is to see if it still functions as well after the experiment as compared to before the experiment. Also, other than that, I observe the conditions of the PV panels before and after the experiment. So I take pictures of the junction box, the diode, the wire connections, basically the soldering of the connections, also the MC4 connectors, and also the backsheet of the PV panel. So that is all from me. I would love to hear your feedback and comments to improve my project. Thank you for watching.